Good morning to all. Today I am going to discuss about relation and functions. Before discussing the term relation, I want to give a notions about cross product of sets. Let A and B are two non-empty sets where the elements of A are A, B, C and B are 2T. Then the cross product of two sets is the order pair of elements from A and B. As per examples, A cross B is equal to A2, it is also ordered pair, B2, B3, C2, C3. These ordered pairs we can draw a picture like this way. This is the set A set. His elements is A, B, C, and the sets B, his elements are 2T. Then A cross B is A2, that means 2 is the image of A. We can draw the lines like this way. AT, it is also ordered pair. AT, we can draw a line to this way. B2, similarly B3 and C2, C3, like this way. These elements of the A cross B is A2, A3, B2, B3, C2, C3. Is form a set. We say this like this way. This is a D set. Now, every element of this sets D, this is also can form a set individually. It is also a subset of the sets D. That means A2 is a subset of D. AT is a subset of D, and similarly this set itself also a subset of D. Okay? So we can say that the set A cross B, this is a subset of D. Now we come to the definition of relations. Relations are from a non-empty set A, from a non-empty set A to a non-empty set B, non-empty set B is a subset of A cross B. A cross B. In the order pair, and the second element is the image of the first element, which we have got in the early stage. Let us see an example. Let A is equal to, his elements is Dasarath and Ravan. B's elements are Rams, Lakshman, Meghnad. Are two sets. There is a relations is father of. The relations is father of between the elements of the sets A and B. Then find the relations R is father of. Answer. Let R is equal to relation R. R is equal to Dasarath Ravan. Our relation is father of. So Dasarath is a relation with Ram. Ram is the image of Dasarath. Okay, is ordered pairs are Dasarath, Ram. This is an ordered pair. And another relations, Dasarath, Lakshman. Dasarath, Lakshman. The Ravan's relations is with Meghnad. But Meghnad is the image of Ravan. This ordered pairs we can write like this way. Ravan, Meghnad. This is the relations between Dasarath and Ram, Dasarath, Lakshman, Ravan, Meghnad. We can draw a picture also for these relations. Here Dasarath and Ravan. This is the sets A let, and B sets is Ram, Lakshman and Meghnad. Here the relations is Dasarath with Ram. Ram is the image of Dasarath. We can draw the line like this way. Dasarath is a relation with Lakshman. But Dasarath is not a relation with Meghnad. Meghnad is the image of Ravan. So we can draw these relations like this way. It is a relation. In these relations, this set is called a domain set. And it is called codomain set. And the range is this. These relations also we can write in this way. R is equal to xy such that x belongs to A and belongs to B. This relation is we can write x R y. On the other hand, if the set A has P elements, pth element, and B has qth element, then the relations form A to B has 2 to the power P cos Q elements. And number of A cos B is equal to P cos Q. Then in these examples, here the A has means Dasarath and Ravan, and B has 3 elements, Ram, Lakshman and Meghnad. Then within these sets A and B, the relations will be 2 to the power P term is 2 into Q term is 3. That means 2 to the power 6. 2 to the power 6 means 2 to the power 6 means 64 elements. Similarly, we can calculate the number of A cross B. Number of A cross B is equal to 2 into 3 is equal to 6. Let's like this way. Let us take another example. Express the relation in roster method and write also the domain and range where the relations is x plus 5, where x belongs to 0, 1, 2, 3, 4 up to 5. Answer. The relations, here the relations R is, here the relation R is x plus 5, and x belongs to 0, 1, 2, 3, 4, 5. 0.5. At again R is equal to if x is 0, then x plus 5 means 0 plus 5. 0 plus 5 means 5. This is an ordered pair. If x is equal to 1, then x plus 5, this means 1 plus 5. Like this way, if x is equal to 2, x plus 5 is equal to 7, x is equal to 3, then under this order pair 3 plus 8 5, x is equal to 4, and 4 plus 5 9, and s is equal to 5, 5 plus 5 10. This is the ordered pair of the relations. This relations is, we can write in this way: 0, 5, 1, 6, 2, 7, 1, 1, 6, 2, 7, 3, 8, 3, 8, 4, 9, 5, 10. Here we see that the domain is the first element of the order pair is the domain element. This is the first element. In this order pair, this is the first element, it is the second element. This second element is the image of the first element. Here, this order pair is 1, 6. It is the domain and it is range. And 6 is also a image of 1. Like this way, similarly, other order pair. The domain is and 0, 1. The first element is the domain element. 2, 3, 4, 5. It is a domain. And the range is second element is the range element. 5, 6, 7, 8, 9, 10. Let us take another examples. Examples is relations R in a set A is whose elements are 1, 2, 3, 4 up to 6. As R means relations. Relations is like this way, where x, y, such that y is divisible by x. And find its domain and range. Okay, our relations is answer. First, our relations R is equal to xy such that y is divisible by x. Then our relations will be where the elements of x is 1 and second element is divisible by 1. Then our relations is R is equal to, if we take the first element 1, this then our second element of the order pair will be 1 is divisible by 1. Okay, this means 1, 1. 1 is divisible by 1. Next, 1 is divisible by our order pair is xy. Okay, next elements we can take 1. The 1 and second elements will be 2. 2 is divisible by 1. 2 is divisible by 1. So we can take the second element is 2. The 2 is the image of 1. Here 1 is the image of 1. Next element, if we can take 1 is divisible by 3. 3 is divisible by 1. Similarly, 4 is divisible by 1 and 5 is also divisible by 1 and 6 is also divisible by 1. This is the ordered pair for the elements 1. Next, if we take the 2, this element divisible by 4, 2 is the factor of 4. Kotike 2 and 4 is divisible by 2 and 6 is divisible by 2. Kotike we can write 2, 6 and next 3 another element is 6. 6 is divisible by 6 is divisible by 3 and 2 is divisible by 2. We can write here 2 is divisible by 2. Each element is divisible itself. But 3 is divisible by 3. We can write 3 also. 3. 4 is divisible by 4. 4 is divisible by 4. 5 is divisible by 5. We can write 5 is divisible by 5. 6 is divisible by 6. 6. Is domain is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We should not write the same elements again and again. So we can write only one times. 1, 2, 3, 4, 5, 6. And range is range is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And another 4 is already right, 6 right, 6 right, 2 right, already right. This is the range of the relation. This is the answer of the question.